All right, I want to I want to do this integral right here. Integral of 9 minus x squared minus y squared dv over e, where e is described by this. It's actually the solid hemisphere, right? So if this was x squared plus y squared plus z squared equals 9, we'd be talking the sphere of radius 3 centered at the origin. To say less than or equal to 9 means you take the interior of that. Because you want everything that's closer to the origin than 9. And then to say that z is positive tells me that we're looking at the upper hemisphere. So there's the base, radius 3, and we just have the top thing. And I gotta be careful because a hemisphere is just the surface. I want the solid all inside of it as well. I'm going to integrate across that whole solid. Okay. Now, different pieces I need. The function, 9 minus x squared minus y squared. Simplest thing to do is to probably just say 9 minus rho sine squared phi, actually it's rho squared, sine squared phi cosine squared theta minus rho squared sine squared phi sine squared theta. Right? And then I'm still going to need the dv here. I'm just going to leave it dv at the moment. I may have recognized this ahead of time, but I see a rho sine squared phi, sorry, minus rho squared sine squared phi in both of those. You can factor it out. What's left is cosine squared theta plus sine squared theta, which is 1. So really this just comes down to the integral of 9 minus rho squared sine squared phi. Now, right, if I was thinking ahead of time, x squared plus y squared is r squared, and that's what we saw for r squared yesterday, or the last video. I don't know when you watch the videos, today, yesterday, or tomorrow. dv. Okay. Now the dv is rho squared sine phi. So this is now the integral of 9 minus rho squared sine squared phi times rho squared sine phi d something else, d a third thing, and then I've got to decide what I want to do. This being a hemisphere, my guess is it's not going to make a whole lot of difference. Generally, I usually like rho on the inside just because I think of rho as the dependent variable most of the time. So rho phi theta or rho theta phi, I don't know that it really makes a lot of difference. So setting it up like this, I'm looking at this region saying, well, how am I going to describe that region? Well, for every value of theta between 0 and 2 pi, I have, so pick a value of theta in between. You're looking at essentially a wedge here. And in that wedge, phi goes from 0 out to all the way down to here, which is pi over 2. And then for every value of phi in between, rho goes from 0 out to that thing here. So actually this is a rectangular region or a cubical region here, because I just have constants on the ends. But this integral here turns into this. Now, just like with polar coordinates, you've got to make sure that you multiply this in. Although this came from the dv, it's part of what needs to be integrated. Okay. This one, yeah, 0 to 2 pi, 0 to pi over 2, 0 to 3. So I've got 9 rho squared sine phi minus rho, not beta, rho cubed sine cubed phi d rho d theta d phi. Actually, sorry, d phi d theta is the way I have it set up. To do this integral, I would split it into two. I would integrate just this one because this one splits nicely as a product of something just in rows, just in phis, just in thetas, and this one is the same way. The problem is I can't do it all at once because this has a rho squared and this has a rho cubed, but not too hard to integrate that separately.